everyone, and welcome to today's video. I've got an exciting one for you today. Today we're going to be unboxing Keysight's new HD3 oscilloscope to look at all of its features and to review. Can you believe it? They sent me one. I still can't believe it. I am ecstatic over the fact that they would send me one. So let's get into this thing and see what all this new oscilloscope is about. Now, if you're questioning about why the product box has googly eyes, there will be links to the shorts down in the description about why Boxy Dean exists. Yes, he has a name. Yes, he has googly eyes. Yes, he's the son that I've never had. Let's get started with today's video. So first, let's take a look at this carry bag. So it's a pretty nice carry bag. I mean, it's what you would expect, right? Just a big open whale. There's a probe pouch. The probe pouch has a strap for it, and so just a big whale here. No internal pockets. There's some ribbing here to keep the structure of the bag. But the most important thing about this bag is you have a nice padded front pocket. What you can do with that front pocket, of course, is put your snacks in it. Because listen, if you have to take this thing out in the field, you obviously are going to be there for a while and you're going to have snacks. And then there's this odd little pocket on the back. I'm not quite sure what it is for. It looks like it's for business cards, and that's what I assume it is for business cards. Me personally, I don't have business cards because my boss is ashamed of the fact I work here. Whenever we have guests in, he just says I'm the guy that comes in once a week to empty out the trash. So again, if your workplace is proud of the fact that you work there, you could always put business cards in here. As for me, that pocket will remain empty for the, for the foreseeable future. All right, so we'll move all of this out of the way, and let's take a look at the accessories box. So, as you can see here, or you can't see there because I forgot to move the camera. Let me move the camera, and then we'll see here. So let's take a look in this box. Of course, we have our regular 500 megahertz passive probes, either the N2843A, and there is 4 of them. When I first opened the box, I was like, cool, there's 4 probes instead of 2, but it's a 4-channel oscilloscope. So there are those. And then also included, at least in my box of accessories, are some of these 1 gigahertz passive probes, some of these really high frequency passive probes. There's 2 of them. Of course, this is a 1 gigahertz oscilloscope, and we'll get into that in a minute. And then, of course, here is your logic analyzer cable that goes in the front for all your mixed signal stuff. This is the model N2756A. And then here is a super nice cover to go on it. I mean, this is a super nice, very well made cover. I can appreciate plastics design because we do a lot of that here at PTI. I mean, it's an 1/8 of an inch thick. This is a very, very nice cover, not cheaply built. So I'm actually impressed by this cover that goes on the front of the scope. And then, of course, we have our certificate of calibration for whenever the auditors come in. They want to make sure all of your stuff is calibrated. So, yeah, that's what these is in the accessories box. Let's actually take the HD3 out of the plastic. Now, let's take this thing out of its plastic. Now, I will be completely honest, this is the first time I've taken it out of its plastic because I've been scared to death to use it. So, I'm very happy with the packaging. Of course, this is what everybody's doing now, the custom cut foam pieces. We do that here at PTI too, custom foam pieces for our battery packs. So, let's get this thing unboxed. A little bit heavier than I expected it to be. It's got some heft to it. It's not real heavy, but it does. You can tell like this is not a cheap piece of equipment kind of heft. So let's get the tape off. All right. Also, I love the very ginormous ESD bag that it's wrapped in. They did not want it to come apart, I'll tell you that much. All righty, here we go. Nice carry handle, and there she is, the HD3 oscilloscope. Now let's do the favorite part of any kind of unboxing. We pull the paper off. And look at that. Look at that beautiful screen. I think the screen is matte. Let's see. Is there any reflection in the... Yeah, very minor reflection in the camera. I think this screen is a matte screen. That's going to be beautiful, but look at that. So, before we get much further into this HD3 review, I've got to be honest with you. This is the first time in my engineering career that I've ever used a scope of this class. Now, how in the world is that possible? In college, all we used was the Rygold DS 1000 series. We had the 1102D. And of course, the professors' workbenches and things, they had the nice oscilloscopes, but we were only allowed to use those, as a demonstration. Now that I've been in this industry for this long, I understand why they were demonstration only. So, my experience, 2 channels, 100 megahertz, that was it. And then I started working here at PTI. And so I got into high-end power supplies, high-end loads, high-end power analyzers, high-end data acquisition units, high-end multimeters. That was a learning curve in itself. I'd never used that level of equipment before. So thousands of dollars worth of all this power analyzing equipment. And when I first started working here, guess what our oscilloscope was? I don't know how you're supposed to say it, the Gwen's Tech or the GWN's Tech, I'm not sure. The GW is kind of separate, I'm not sure how you're supposed to say it, but the GDS 1062A, which is pretty much an equivalent to the Rygold DS 1000 series. So I was quite happy, I can use this oscilloscope, and so that was, 7 years ago when we went on with our life. And then over the years, we've talked about upgrading our oscilloscope, but then we needed a 3D printer, so we bought that instead. And then we needed better power equipment. I say needed. We wanted better power equipment. And so, you know how engineers are. They're kind of like, well, it's kind of like little kids, You eat your vegetables to grow up big and strong, or have an ice cream cone. Well, the little kid's always going to go for the ice cream cone. It's like either, for an engineer, it's like either, do you want the oscilloscope that's going to help you, in your lab and stuff, or do you want the fun CNC router or 3D printer that you can have fun with? Engineers are basically like little kids. That's basically what we are. We're just really happy with our toys, and if we get to eat our snacks on time. That's basically how you keep engineers happy, is we want to play with our toys and eat our snacks. So we're basically like big little kids. So that's why we've never upgraded the oscilloscope, plus our other power analyzing equipment does really help to fill in the back end where this thing is lacking, but boy is this thing lacking. It is a chore to use it every time we go in the lab to do something complicated. So as I'm reviewing this, I have read the demo guide, I've read the user guide, I've looked through all the specs and everything, I've looked at other scope specs, I've tried to do as much research as I could to learn as much about it as I can. But this is the first time I've ever used a scope of this class. So I'm probably going to geek out at things that are industry standard. I'm probably going to geek out at things that are probably normal for oscilloscopes like this. And just be happy with me, because I'm happy with this thing. I'm already happy with it out of the box, and I haven't even booted it up yet. So let's get into this thing and see what it can actually do. So let's take a look at the interface of the HD304. Now, one thing that I did have to do, the screen is a lot more reflective than I thought. So I did take and put a black background behind the camera. We can still see the camera and the reflection, but behind the camera. So screen's not quite as matte as I thought, but it's not near as reflective as it would be if it was a normal screen. So this is a 10.1 inch WXGA screen. It's 1200 by 800, and it is a touch screen. So I'm excited to get into that. Never used a touch screen oscilloscope before. These are our 4 channels down here. I do like the color codes, and then these are our active probes, which I've never used any active probes before, but I'm sure it would be cool to use one of those. And then, of course, here's a model number. This is the HD304 MSO, which is the mixed signal oscilloscope. This is a 1 gigahertz bandwidth scope. I don't know if I'll ever get to 1 gigahertz in a signal doing what I do, but 1 gigahertz bandwidth scope. It is a 14-bit scope. So for my research, all the other scopes are 12-bit in this kind of range. And so 14 bit's a lot, because that gives you 4 times the vertical resolution that it would if it was a 12-bit scope. So that's pretty cool, 14-bit scope. So if we come over here to our buttons, these are really nice rotary encoders, both for your horizontal and these are some kind of rotary encoders. However, they don't have any detents. They're just kind of free rolling. Of course, you have all your buttons and things. Everything just oozes quality. Now, one thing that I am unfamiliar with is you have your vertical here, but then your horizontal is up here. I would expect, you know, your waveform manipulation to be, you know, kind of together, then your trigger to sort of be up here maybe, and maybe your markers to be up here with the trigger, those two to be together. I don't know. Again, I haven't messed with an oscilloscope that much. And of course, 2 USB ports. And they better be able to charge my phone. We're going to test that in a minute. That is something I am going to test. And then, of course, your channel selectors here. So let's turn it around. Bumpity bump, bump. Let's turn it around. So here's your back of the panel. Of course, you have the power cord input here, LAN, another USB port. I assume that's on the same bus, but I wonder if it's a special USB port. I'll have to look that up. Display port, that unfortunately is not enabled right now, but that'll be enabled in the future. Then you have a USB-A here. Then you have your waveform gen out, your auxiliary out, your trigger in, and then you have your logic analyzer input. And that looks like just a normal, you know, 100,000th pitch header. So I do wonder if you can make your own probes to go in that interface. That may be an interesting video for later. Also, I noticed, so you have your rubber feet on the back, but they overmold this way, and then there's rubber feet here. So I assume that you can lay this thing down for some reason. I'm not sure why you would need to lay it down flat on its back, but look at that, see? So I'm not quite sure why you would need to lay it down on its back, but that is a feature. One thing it does not have is a Visa mount on the back. I did notice that a lot of the other oscilloscopes have a Visa mount, but again, this is a portable scope. This is meant to go out in the field. That's why I assume these bumpers are here so you can lay it down for some kind of configuration. And then we come to the handle. So the handle is very, let me bend it over here. The handle is very, very nice, very, very, very well made, and it's even got a rubber overmold for ease of carrying. So they did spend a lot of time trying to make this a very nice and very easy to configure portable oscilloscope. So let's get her plugged up, let's get her powered up, and see what she can do. So I almost forgot to show you this beautiful cover and how it goes on. I mean, it just slides on beautifully. Watch this. Oh man, it just slides on beautifully. Pulling it back off and then sliding it back on. The whole review video is just going to be me doing this. Just me. Oh, that is so satisfying. It's just going to be me doing this. I just want to take a second to compare these two display sizes. Look at the size difference. I mean, if your boss doesn't believe the signal's big here, he definitely will believe it's ginormous here, because look at the size difference just in the displays alone on these oscilloscopes. Hey boss, we got a little bit of a problem. I brought the scope in here to show you. We got a pretty bad spike we're looking at.
What am I looking at? Well, that spike ain't but 2 inches tall, 1.5 inches at best. Well, back in my day, we didn't even worry about anything over 4 inches tall. You young roof stoppers always wanting to read us on stuff, copying money. You need to just do better. Until that spike's bigger, we ain't doing nothing for the project.
Okay, so I did what you told me, and I did better, and I got a bigger oscilloscope. Now, look at the spike.
Oh, that spike is huge. Oh, good heavens, my heart. Oh.
So one little funny tidbit, I went to go plug the scope up, and Keysight didn't send me a power cord. I think they forgot to put it in the box with the demo unit. So this is just a regular IEC cord I had laying around, but this is not the Keysight official cord. So let's get it started up and see what happens. So let's hit the power button and see how long it takes to start up. Because when you have a scope like this, it boots up. Listen, you know you got quality equipment when it takes a minute for it to boot up.
I think I need an ambulance.
All right, so I'll zoom the camera in so we can take a look at this beautiful screen. Now, I'm not even going to begin to act like I know what I'm doing, but I did read the demo guide, so there are a few things that I want to try out first. The first thing is The problem with that Instech meter is that it only has the one screen, and so we got to fight with two signals on the same screen. So this is supposed to have the ability to be able to divide out all of your signals. So I do want to turn on all 4 channels. Okay, here are your channel settings. Can I drag this? I can drag this. Look at, ain't that fancy? Can I dock it anywhere? Can it like, no, it don't. Oh, did I lose it? No, I didn't lose it. Can I lose it? Can I put it so far over it'll get lost? No. Can I, is there, no, I can't lose the box. Okay. So this is all my channel settings. So that's my scale. Oh, that's my scale, my offset, my coupling, my impedance. That would be 50 ohms and 1 meg for my 1 in 10 times. Now the 40 megahertz bandwidth limit, that is per channel. However, I did read in the guide that that will be a selectable megahertz level for each channel in the near future. And then what happens if I hit probe? Okay, so it can detect Keysight probes. Let me grab, you know what, I'm going to grab a probe and see how that works. So this is just one of the 500 megahertz probes, and I do want to show you something. So I thought this was super neat. You have a little holder for your ground clips so it don't slip out. I've never seen a probe that fancy. I think that's cool. Just geeking out over it. Look at that. Look at that. That is so cool. But let's plug this into channel number 1. Now, I assume that it just goes in there any which way. And look at that. It automatically recognizes the probe. That is awesome. So it automatically recognizes that the probe is attached, automatically sets it up and everything, so that way it is ready to go. That is pretty cool. Since we have the probe attached, let's just attach it to the probe compensation so we can get a signal going here. So let's up our vertical here so we can get the signal going, and then of course adjust our trigger to where it'll stop. Yeah, there we go. So let's just do that. Markers must be on. Oh, I accidentally hit the markers button. I have to admit, every time I touch something wrong, it does tell me I did something wrong. That is very nice. And then, of course, it has this notification thing here too, that every time I do something wrong and every time I touch something. So that's pretty nice. I can't just mess it up like I will with that Instech meter and not know what I did. So, let's take and see if we can get this grid to do any different. Because I don't like this. I'd rather have it in the 4 grid mode. So, I think that setting is, no, not there, here. Now, I got to admit, I don't know if it's my meat fingers or the touch screen, but when I hit stuff like, I'm not, I don't know, I think it may be my big meat fingers, but I'm having a little bit of trouble hitting the little stuff. So what would this be? Okay, that's going to turn on your okay, there's your FFT. Okay, so that's going to turn on all your stuff. Waveform layout. Horizontally, overlay waveforms. Okay, tile horizontal. Okay, that's what I was looking for right here. This is exactly what I was looking for. So are we still on, okay, we're on channel 1. That's not what I wanted. I wanted this. So there's channel 1 right there. And then channel 2, 3, and 4. But what if I want to add more stuff in? So if I want to add math, okay, what if I want math on a separate, what does the custom layout do? Oh, okay. So let's disable channel 4 and put in math of channel 1. Okay, that overlays. I want this to go here. This to go to drag and drop. Drag and drop. Okay. So then I can have my manipulated waveform here and then my original waveform here. Oh, that's very neat. That is very neat. I wonder if I can change. Okay, that's all my math stuff, of course. But I wonder if I can change. So what if I didn't want this in math? I want this to be the FFT. Okay. FFT. Okay. Custom layout FFT2. Okay. Okay, that is okay. That is pretty neat. That is pretty neat. That okay, that's impressive. I like that. I like this very much. This is a very, very nice interface. Let's see what else we can get into. So if I come over here and I hit markers, let's just, by the way, that blue is a very nice blue. I know it's a little washed out on the camera and it's a little hard to see, but that blue is a super, super beautiful blue if you could see it. It is just a great looking blue. So let's just, are we on channel 1? Let's just hit markers. Let's see what that does. Oh, okay. Let me pull that down. Okay, so we've got our X and we've got our Y. Okay. Let's disable the X and let's just go with our Y. Now, is there a auto marker? What happens if I just hit the buttons? Okay, that's just a selection button. Mode manual. What about track waveform? I don't know what that did. What about binary? No, that's source here. So track waveform. X1 source X. I don't know what I'm doing. Hex. Nope. So manual. Manual is what I need. Okay, so let's do Y1 and Y2. So let's select Y. Markers must be on or unlocked. Okay. Well, I thought I had markers enabled. Do I not have markers enabled? Wait, hold on. Oh, because I'm moving the X one, not the Y one. Okay, this is for the X, that's for the Y. Okay. So I'm moving this here, and then I select it to move my Y. Okay, that's together. So, okay, that's Y1, Y2 together. Okay, that's pretty neat. So then I can measure this. So it'll give me my lower threshold, my upper threshold, and then my my delta. So that's pretty nice. Pretty nice right there. Let's turn those markers off. Now there are some other specs about this scope that I'm not sure if I can quite verify. So it has a 1.3 meg waveform update rate for the screen, 3.2 gig sample rate, that's right here, and then 100 meg points, that's supposed to be per channel of memory. So I have this set up here, so if I do this, then it will auto scale the meg points here, and I'm not sure if that's just because of what it doesn't need. So does it just need 32 meg points? I'm not sure, and this is just the signal coming from the probe compensation, but I can take and force it to do the max for the channel. So what I want to do is I want to enable channel number 2, and then I want to see, is this just for, okay, is this just the global for each? So I wonder if it will, well, see, now I've got all 4 channels enabled, and then I can change this, and it doesn't change that scale value. So if I change, why am I not in channel, I want to be on channel 4. So, okay, that's odd. Will it not let me change channel 4 because I don't have a signal? Oh, I can change the vertical of channel 4, but I can't change the horizontal. Is the horizontal, okay, is the horizontal just per, okay, so I can change the vertical per channel, but I can't change the horizontal per channel. Okay, that's something to know. I'm not sure how high-end oscilloscopes work, so I can change the vertical per channel, but I cannot change the horizontal per channel. That is a full, it looks like, time-based thing for the whole entire screen. Now, what if I change it to grid, though? So if I change it, what if I change it to grid? So if I go custom layout, or I just change it to stack waveforms horizontally. Okay, now can I change the horizontal time base for each? No. Still change the vertical, but I can't change the horizontal. So I don't know what that means. I don't know if I'd ever need to change the horizontal per channel differently, but it's just something to look at. But if you look, I've got all 4 channels running, and it still says I'm forcing 3.2 gig samples a second at 100 meg points of memory. Now I know that 100 meg points is per channel. I read that in the specs. So yeah, it looks like it's doing what it says it's doing. Again, I can't really test it, but I do have a test that I want to put it through, and it's something that I have to do almost weekly here at PTI.
Is there anybody still there?
So I do have an experiment set up here where we're testing an inverter and battery together. Now this is something that I do a lot here at PTI. By the way, you hear me mention PTI, that's Protechnologies Incorporated. They are my employer. This is their lab that I work in and record all of my videos. So special thanks to them for sponsoring this video and letting me record here. Sales at protechnologies.com if you would like to order a custom battery pack from us. But I have this this setup here. So the problem I have with a lot of times with batteries is surge current. So it's not continuous current, but it's surge current. So this is a 24 volt Samlex inverter, and this is a 24 volt battery pack. Well, the problem is this inverter has huge input capacitors and then huge output capacitors on the AC side. So we have to make sure we set the BMSs to where their trip limits won't trip whenever this is initially starting up. So I have channel 1 here set up to monitor the battery pack voltage. I want to know when it dips. And then I have channel 2 set up with this, again, this is either a Gwinstech or a GW Instech, I'm not sure, but this is a GCP 300 current probe. Of course, a lot of people make these, but I have that set up right here. Now, I did leave the scope. If you look here, the sample rate and the memory depth is still maxed out. So I left that there just because I think I can. I think I've got it set right. But I'm going to adjust my trigger here for channel number 2 because I want my trigger to be on channel number 2. Okay, I found it. So you go to your menu here, and then you can set your source to external. Well, you can set it to all sorts of stuff. You can set it to your digital stuff. You can set it to your wave generator, external, but we want to set it to channel 2. So we want to set our trigger to channel 2. Now, why can't I see my trigger? I was using the wrong knob. Here's my trigger. So this is measuring at 10 millivolts per amp. I'm expecting this to be around 150, so I just want to set this, I don't know, 25 millivolts. 25 millivolts will be fine. So I'm going to set this to a single trigger. And if you watch closely here around this point, you'll see an arc. And that arc is what is charging up those input capacitors for this inverter. And that is what we want to capture. We want to capture the voltage dip of the output of the battery, and we want to catch the current spike coming out of the battery. Alrighty, so let's take a look at our results. So this is our voltage dip, and then this is our current spike. However, if you notice, it's in the wrong direction. Do you know why? Because I have the current probe flipped over. So we can still do the measurements on it, but I do have the current probe flipped over. So let's look at our voltage spike here first. Let me bring it down to where it's in the middle of the screen because that's just a pet peeve of mine. Now, when I go horizontal, it's going to zoom in both. But is there a little, yeah, there is a little blip there. That's what I wanted to look at. I don't think I've ever seen a little blip like that on that little cheap scope. There's a little blip there. Oh, that is interesting. So this is the 24 volts here, and then that is spiking up to 30 volts. So there must be some kind of inductive component to this that kicked back some voltage. That is interesting. I have never seen that before. And so that's already worth it for this scope to be able to see things like that, because that is very important to know for your battery pack. But you can see the voltage dip down. Let's put our markers here on channel number 1. And so let's just do, wrong button, wrong one. I know, quit yelling at me. Boy, this thing is touchy when it comes to hitting the wrong thing. Will that automatically go away? That won't automatically go away, will it? Yes, it will. Thank the Lord. So we look at our voltage delta. So I dipped about 6.5 volts, 6.625 volts. All right, now let's go over to channel 2. Will my markers automatically change sides? They won't. Can I have markers on both sides? How would I? Hit the button. Oh no, that's not. Can I get markers on both sides? I do not believe I can get markers on both sides, or I just haven't figured it out. how to do that. So let's do channel 2. Let's turn the markers off here and then hit markers. No. Okay, so markers, channel 2. Okay, so markers are on channel 2. Markers are all the way up there for some reason, and then we'll do Y1, which is here, and then Y1, which is here. Then we'll do Y2, which is down here. So that's a delta of 1.5 volts, which would be 150 amps. So 150 amps delta right here would be 150 amps. So 150 amps right here, which is what I was expecting to power up this inverter. Now, stage 2 of this test. Now we actually have to turn the output of the inverter on and see what the spike is drawing back out of the battery pack. So if I hit clear display, is it ready to go again? I don't know if it's ready to go again. Okay, so I need to go back to channel 1, horizontal, and redo my vertical. I need to go back to channel 2 and make sure my horizontal and vertical are good. Now, is my trigger for channel 2 still set to, still set to 25 millivolts. So clear display, I'm ready to go again.
I think I see a white light.
Okay, so for the second part of the test, the DC capacitors of the inverter are charged. However, the back-end AC capacitors are not. So when I flip the switch, the rest of the system is going to boot up, and then it's going to have another draw out of it. So for this test, I noticed before that I kind of maxed out my my horizontal range by doing the memory the way I did. So what I'm going to do is I'm going to put this not in manual mode, but it's going to be in auto mode. And then I'm going to change my horizontal to, let's say, 500 milliseconds. That's interesting. This is 500.6 milliseconds. Where did the 0.6 come from? I don't know. But 500 milliseconds, because I want to see it'll be a ramp up and then it'll be a curve down. So I want to see that curve down. So like right now, it's auto scaled to 100 meg samples a second with 100 meg points of memory. So let's try it like that. I want to see what it does. All right, so we'll flip the inverter on. You'll see this light bulb come on. Okay, that is a good, clean spike right there. So let's measure that. I'm going to turn this off so I'm not staring at this light the whole time. So let's get our markers out. We're on channel 2. Let's get our markers out. I want to see what this current spike was. So what cursor am I on now? So we're going to zoom that in a little bit. We're going to have to. So I am curious to see, so if you look here on the waveform, there's kind of a haze around it. I do wonder what the haze is. I'm sure it means something. I'm just not quite sure what it means. But looking here, so we go there and then we go to Y1, and Y1 is where it should be. So our delta is 650 millivolts, which is 65 amps. Now I want to see what our continuous running current is. So let's do that. We'll scroll over, zoom back in, and I want to put Y1 at 0. I'll put, well, there we go, 0. Nope. That is very sensitive. That is extremely sensitive. So I'm going to put Y1 on 0. No, I just got it. No. And then Y2 I want to put here just to see what the continuous current was. So the continuous current was what? 2.5 amps? Something like that. So, okay. That's pretty neat. That's pretty neat. So this is something that I do, a lot of times, something that we do here a lot of times. It's a practical test. A lot of the other oscilloscope reviews that you just plug a waveform generator into it. Here's what it does. This is a good practical test of what I would actually use this for every single day.
I see the angels with their wings coming to get me. Oh no, those aren't angels.
Okay, now for the moment everyone's been waiting for, can this oscilloscope charge my phone? Let's test it out. Look at that, charging my phone. Now, it is slow charging, 3 hours and 37 minutes till charge. It is slow charging, but it is charging my phone. So that's something. I do wonder if the USB port on the back will charge any faster. No, charges at the same rate. Okay. But it can charge my phone, so this oscilloscope wins in my book. I don't care if the rest of it's broken. If it can charge my phone, this oscilloscope is a win. So that concludes my HD3 oscilloscope review. Now, did I do it justice? No. But you know what? I'm okay with that because I had a good time. I enjoyed reviewing and messing around with this oscilloscope. It was just fun to mess around with some new equipment and something that was this level of quality. It was just fun to do. When I use this little thing, it's a burden. When I was using this thing, it was a great experience. It's like if you have a nice car or you have a nice phone or four-wheeler or video game system. When you use it, it gives you pleasure. It gives you joy because of the experience it provides. And this provided me a great experience. I just enjoyed using this oscilloscope. So I am thankful that Keysight sent it to me. I'm honored. I'm privileged that they would send me something like this, even though it outclasses me. I greatly enjoyed reviewing it. Now, did I make some mistakes in the video? I probably did, since this is the first time I'm using something like this, but I enjoyed it. So that's all I've got for you today. I just enjoyed making content about this oscilloscope. Now, I do plan to make more videos about the oscilloscope. I want to get into the logic analyzer portion, and it has some automated test routines that I want to get into. But for right now, I'm just happy it got sent to me, and I'm just happy to fool around with it and see what its capabilities are. I probably got about 30% into its capabilities. There's about 70% of it that I'm probably have yet to discover about what it can do, but I'm happy right now with my 30%. So I hope you enjoyed the video as well. Please like, share, subscribe to the channel, all of those kind of things. And make sure you stay tuned for other HD3 oscilloscope content.